Section 7.1, Inverse Trig Functions. We're going to look at y equals sine x, y equals cosine x, and y equals tan x and their inverses. So what I started off with is a graph of sine. Okay, so I graphed 2 cycles of sine. Sine starts at 0 and goes up to the top of the amplitude, middle, bottom, middle. Okay. So when we talk about inverse trig functions, remember that inverse trig functions have to be 1-to-1, which means if a function is 1-to-1, it should pass the horizontal line test. So if you notice, if I were to draw a horizontal line here, sine would not pass the horizontal line function, or the horizontal line test. So what we have to do is we have to restrict the domain here. And we're going to restrict it to an interval where sine is 1-to-1. Now, typically, we restrict sine, okay, from negative pi over 2 to pi over 2. So if we look just here in the middle, okay, at just this portion of the sine function, we get a portion of the graph that would pass the horizontal line test. And it's only on this small interval here where the inverse trig function can be defined. So we're going to talk about a restricted sine function. And this restricted sine function is going to have a domain from negative pi over 2 to pi over 2. And then the range on this restricted domain is negative 1-to-1. So when we talk about inverse trig functions, we're not talking about the whole entire sine curve. We're just talking about this small restricted domain, right? So when we go to define the inverse sine function, okay, one way of writing that is y equals sine inverse of x. So we take the -1 inverse notation here, or it can also be written as arc sine. These are the same things. Okay. Now the relationship between sine function and its inverse, remember inverse functions switch all the x's and the y's, and because all the x's and y's switch, the domains and ranges switch as well. So the domain of sine inverse is going to be the range of sine. So the domain here is negative 1-to-1, and the range is negative pi over 2 to pi over 2. Now, what I'd like you to realize is that this restriction correlates to 2 quadrants on the unit circle. If we were to go from 0 to pi over 2 on the unit circle, I'll just go ahead and draw a unit circle here. Pi over 2 to pi to 3 pi over 2. Okay, and here's my unit circle. From 0 to pi over 2, that's quadrant 1. Okay, so this portion of the graph correlates to quadrant 1. Right? This portion of the graph here, from 0 to negative pi over 2 on the unit circle, 0 to negative pi over 2 is down here, because if it was a negative angle, we'd go clockwise, right? And so this portion of the graph is quadrant 4. Okay, so we're restricting the sine curve to quadrant 1 and quadrant 4. Right? Now the way the inverse trig functions work, if we know that sine of pi over 6, right, that's 30 degrees. Sine of 30 degrees is 1/2, if you remember. Okay, the point on the unit circle associated with 30 degrees is rad 3 over 2, comma 1/2. And the sine value is the y value. So we know that sine inverse of pi over 6 is 1/2. Well, when we do the sine inverse here, we're going to put the 1/2 into the sine inverse, and it should return back the angle, okay, pi over 6. So if sine of pi over 6 is 1/2, sine inverse of 1/2 is pi over 6. Let's go ahead and do the other one. Sine of pi over 4 is 1 over rad 2. So sine inverse of 1 over rad 2 is pi over 4. Okay. If sine of pi over 3, which is 60 degrees, is rad 3 over 2, then sine inverse of rad 3 over 2 is going to be pi over 3, or 60 degrees. Now when we do the negative angles, right, we're going to be doing negative pi over 6, negative pi over 4, negative pi over 3, okay? So if we know the sine of negative pi over 6, right, remember that's going in the clockwise direction, and so the x value is going to be the same, but the y value is negative, right? So sine of negative pi over 6 is negative 1/2. Therefore, the inverse of negative 1/2 is negative pi over 6, right? And so on and so forth. So sine of negative pi over 4 is going to be negative 1 over rad 2. So sine inverse of negative 1 over rad 2 is negative pi over 4, right? Now, negative pi over 4 is the same thing as 7 pi over 4, right? They're coterminal. But when we write those answers, we're always going to make sure that our answers fall within those two quadrants, okay? We're going to make sure they fall between negative pi over 2 and pi over 2. So if we were to put 7 pi over 4 here, 7 pi over 4 is not within the range of our sine function, so that would be incorrect. So make sure that your answers fall between negative pi over 2 and pi over 2. Let me go ahead and do sine of negative pi over 3, okay, is going to be negative rad 3 over 2, and therefore sine inverse of negative rad 3 over 2 is going to be negative pi over 3. Now the quadrantal angles work as well. So the point here at pi over 2 is 0, 1. So the sine value is positive 1, right? So we know that sine of pi over 2 is 1, which means that sine inverse of 1 is positive pi over 2, okay? And same thing down here, okay? We know that sine of negative pi over 2, if I were to get that point on the unit circle at negative pi over 2, the point on the unit circle is 0, negative 1. So sine of negative pi over 2 is negative 1. Therefore, sine inverse of negative 1 is negative pi over 2. Now what I'd like you to do is kind of call these angles and ratios, right? So we're putting an angle inside the sine function. All of these are angles. And so when we do the sine of an angle, we're going to get a specific ratio, right? 1/2, 1 over rad 2, rad 3 over 2, all of these are ratios. Now when we do the inverse, we're putting the ratios into the inverse sine function. And when we put the ratios into those inverse sine functions, we're getting the angle back out. So the answer to an inverse trig function is always an angle, okay? And those angles should fall between negative pi over 2 and pi over 2. So what I'd like to do is I'd like to kind of pull these points on the sine function, okay, these 3 points here so that we can graph the inverse. Let me zoom out. So on the sine function, I know that negative pi over 2, comma negative 1 is a point on sine. I know that 0, 0 is a point on sine. And I know that positive pi over 2, positive 1 is a point on sine. So because this is the inverse function, remember the inverse functions swap, right? The x's and the y's swap. So the point on the inverse function here is negative 1, negative pi over 2. 0, 0 makes, no difference. But then if I switch these, I get the point 1 comma pi over 2. So the ratio is negative 1, the angle is negative pi over 2. The ratio is 0, the angle is 0. The ratio is 1, and the angle is pi over 2. So if I were to graph y equals sine inverse of x, or arc sine, okay, what's going to happen is that the x and y coordinate, x and y axes are going to swap. Okay, the independent variable here, the x values are going to go from negative 1 to 1. Okay, so the x-axis, I'm going to label the points negative 1, 0, and 1. And on the y-axis is what's going from negative pi over 2 to 0. So I'm going to put negative pi over 2 on the y, 0, and then positive pi over 2. So I'm going to plot these points. Negative 1, negative pi over 2 is here, 0, 0 is here, and 1 comma pi over 2 is here. Now this sine inverse function is a finite graph. Okay, it's only going to be this long. It's going to go from here to here. So what I'd like to kind of show you is when we do inverse functions, they're reflections. Remember that, where it's a reflection over the line y equals x. So this one's kind of a little bit easy to show you, right? If I were to draw a y equals x line here, that diagonal line, oops, kind of messed that up. The diagonal line, okay, y equals x here. We're going to reflect this graph over this y equals x line. So if I were to reflect this portion, it's going to be curving down like so, right? So from 0 to negative 1, it's going to be curving down like so. And then from 0 to pi over 2, if I were to reflect this part of the graph over y equals x, it's going to be curving up, right? And so this part of the graph is curving up. Okay? This graph is sine inverse. It is a finite graph. It has a beginning and an end. It doesn't go off to infinity in either direction. Okay, sine and sine inverse. So what I'd like to do is go ahead and show you the same thing for cosine and tangent, but my videos can only be 15 minutes long, so we're going to have to do this in a series of videos. And so this is going to conclude video 1 on inverse trig function.